Fine. So let us start. So what we discussed in the last class, we discussed many types of different data warehouse existing in today's scenario, right? So we saw what is a data warehouse. Okay, so basically it stores data, but it does something extra as well. What are the extra things? It analyzes those large amount of data, fine, for a particular organization. So we also saw what's data mart, what is data lake, right? Data mart is focused on a specific area. For example, finance, something to be dealt in finance, it can be done in a financial data mart. Okay, if you want to deal with, for example, some of the data like of the students, then that is personal data. So that is kind of a different type of data, like categorical data, and you need to have another data mart for that, right? How you will do with data lake? Data mart usually has less than 100 GB of data storage capacity, whereas data lake has a bit more, and data lake can store both structured and unstructured data, right? And it can take in anything you give. Data lake is like that, whereas data mart, you need to give only structured data. Yes. So based on whether there should be different data marts, and then it should be fed into a data warehouse, or it should be first a data warehouse and then fed into different data marts. Depending on those two scenarios, we have two different cases and two different approach by different data scientists. One is Inmon and another is Kimball. Okay, so based on these two scientists, they had different thoughts of mind. Maybe one person said that we should have all the data marts in the first place. Let us collect data from specific organizations, okay, specific departments, financial department, all. Then we will feed into data warehouse. That is Inmon's approach. And Kimball said that no, we will go bottom up approach. That is, first we need to have data marts and then the data warehouse. Okay, the other way around. So these two cases we will be discussing in today's lecture, right? And if time permits, we will discuss today's schema, like what are the different schemas in which you can have data warehouse. There are two types, to a star schema and snowflake. Okay. If possible, I will provide a link also, Geek for Geeks. It has a very nice introduction for both star and snowflake schema. So as you can see, what the data warehouse does, so it gathers data from different areas, fine, and then different areas. This should give you an idea that these are coming from at least different data marts also. Maybe finance, maybe your personal data, maybe anything else you can suggest. Any other data you can think of. So these are just two examples, two different examples. So it integrates and stores the data, and most importantly makes it available for analysis. Last time we saw many different kinds of data warehouse, which which are available on premises, which are available in cloud, which are available both online and cloud, right? And we also saw Google and your who AWS, right? And IBM, they were having their own data warehouses. Okay, they released their own data warehouses, which many different organizations they use, right? So, and we saw that many different data warehouses were focusing more on machine learning and deep learning analytical processes on the large sets of data, whereas others were giving more priority to the privacy of the data. Okay, others were giving more importance and emphasis to the privacy of the data, right? So, depending on the platform, you can check which data warehouse your organization needs. Okay, you can check which data warehouse your organization needs. Okay, you might be a very big organization in a very cyber attack prone area where you need more privacy concerns, right? You have to address more privacy concerns. In those cases, you cannot take a data warehouse which focuses mainly on machine learning analysis or deep learning analysis or different analytical processes. You have to consider the effect of privacy also. Okay, that's what one of the snowflake data warehouse was there last time we saw. It is giving 50% of its efficiency in privacy, right? Fine. So these are the ideas. Maybe these things, okay, you already know about this. Okay, so we saw this one, right? On premises, on appliances, and on cloud, all different kinds of, many different, around 10 15 different data warehouse we saw last time. Okay, different types of different names we saw. Fine. So maybe we can come to the data warehouse architecture in today's class. Okay. So we'll discuss two approaches. One is top-down approach. Another one is down-top approach. Instead of calling down-top, we call bottom-top. Okay. So it's the same, right? So top-down approach, it's by Inmon. Okay. One of the data scientists, Inmon. Okay. So it's also known as Inmon criteria. Okay, Inmon's criteria. So top-down, what is there in the top-down approach? You can see an organization must decide on all data definitions, cleaning, and business rules before any data enters the data warehouse. So before any data enters into data warehouse, they suggested that something else need to be done. Why? Why we need to think of this approach? Because last class I had taught you that once the data enters into a data warehouse, it is very difficult to change. Data warehouse is very difficult. Once the data enters into the data warehouse, it is very difficult to change the data in the data warehouse, right? Why we saw last time. Okay. So those who still find it new, I suggest you go back and see it. But that's that was one of the most important point in a data warehouse. Once any change you cannot do in a data warehouse once it enters. Okay, so therefore try to make any changes, any cleaning, anything possible before it enters the data warehouse. Okay, so that's why people thought that why not we have this approach before we directly put the data into the data warehouse, let us collect it from different data sources. Okay, so as you can see here, so these are the different data sources, data source 1, data source 2, and it is being fed here, and after that it is going through this ETL transform, right? Extract, transform, and load, right? And then you can feed into the data warehouse. So you can see like this is Inmon's methodology, right? So you can see this kind of scenario is being planned if you have if you want to plan data warehouse at an enterprise level. Okay, so enterprise wide data warehouse. Okay, so for if you have an enterprise wide data sources and data you have to analyze, then this is the approach you should be following. Okay, top down approach. So you can see the first and foremost rule is to create. Let us go back here to the picture so that you can understand. So yes, collect data from different sources here, data source 1, data source 2, then apply the ETL transform like extract, transform, and load. After it enters the data warehouse, then you split into different data marts. Okay. I mean, after you have all the data here, then you decide, yes, this is the finance. Okay. This is the information like personal information. Okay. So then it goes to different data marts. After it is segregated like this, it is being segregated. Okay. After you have a chunk, you are deciding which department it will be going. Okay, so after you did that, so each is a data mart because each is specialized in a particular department, right? Maybe that's what data mart is. They focus on a particular area rather than all. Okay, and then it is available for further analysis. Yeah, then it is available for further analysis. Like you can see here, data mining. Okay, you can do. You can use BI tools also. Okay, you can use BI tools also here. Okay, to I mean business intelligence tool or any data visualization tools you want to. Okay. However, it is a good process because in ETL process here it goes through normalization. Okay, all kind of normalization what we have discussed in the class. It is going through all of them, right? Fine. So, but one of the disadvantages is like it has more number of joints. Okay, I mean more number of connections. More, it's a very complicated network. What do I mean by joints? These are the joints. Okay, so these are the joints here you are seeing. Okay, it has lot of joints. So if it had more joints, that means yes, it will have slower reporting times. The computational time will be higher, isn't it? So therefore, you can see slower response times. Okay. And of course, there is like lengthy upfront work, like you have to collect data from different sources. And again, after that, you have to segregate them. So this is one of the approach. But now let us see the other approach where you can see the difference in between both of them. Okay. So as usual, it's the same. This part is almost the same in both of the approaches, this part. Okay. That means you collect data from different data sources, data source 1, data source 2, use it, like feed it for ETL process like extract, transform, and load. Then instead of directly feeding to the data warehouse, you feed it into different data marts. So here data marts come first. Okay, can you see this is coming second, right? So can you see the difference between this one, the bottom up, and the top down approach? Here first the data warehouse came here and then the data mart. Okay, but here it's different. Here the first data mart comes. Okay, so after you have used the ETL transform to your data sources, different data sources, you feed it into different departments like finance or personal information specific using data marts. After that, you integrate them into a data warehouse. Okay, so you can see here. Okay, and then after that, it is available for any intelligence tools like any type of analysis like BI, Power BI, or Tableau, or any business intelligence tools for your data visualization, or any kind of analysis you can try to do here. Okay, fine. So these are the two, different approaches you can think of. So the second approach we are looking here is known as the Kimball's bottom-up approach. Okay. So we looked into two different approaches. One is Inmon's approach and another is Kimball's approach. One is top-down, another is bottom-up. Okay. So which one to use? It's depending on your project which you want to use. If you have to deal with enterprise wide data, okay, very big chunk of data, you have lot of data, then it is usually suggested that you go with Inmons because it is meant for enterprise level data warehouse process, right? So just a bit of theory here. Okay, fine. Just like you should know about this. I mean, it should not be new to you, if at all, like you hear them, right? So data mart. What is our concern here? At least you should be knowing about few technical terms. That is, what is a data mart? What is a data lake? Okay, what's the difference between them? Which one to use when, right? And how different layers of data warehouse is there. Okay, first, what are the different types of methodology? One is Inmons, another is Kimball. Okay, which methodology, which approach to use when? Okay, if you have an enterprise level data warehouse, it is better to use the Inmons approach. That is a top-down approach, where the data warehouse come first and then later segregated into different data marts. Okay, then it's your Kimball's bottom-up approach, where different data marts come first. Okay, and then it is being fed into different data warehouse, like to the data warehouse using integration process, right? And then it is available for different analysis or BI, business intelligence tools, anything like that. What kind of analysis you can do. So these are different layers. Like, what is a data warehouse? You should be knowing it in this few slides. Okay. So first, there are different layers. Okay. If it is being asked, what are the different layers of data warehouse? Or maybe a specific example will be given, like maybe your case, like suppose we have a group of students, group of 100 students or 500 students or 800 students studying in a university. Okay. And we have to analyze those data, like of the students, how much mark they secured, which branch are they going, which specialization are they doing, are they having any health backgrounds. Okay, so that the organization should know about it. Okay, if someone has a claustrophobic things, then they cannot be made to sit in a closed arena or a closed room, then they hallucinate, right? So therefore these criteria should be known by the organization or the university first before planning any activities, right? Or before, some may be lactose intolerant. Mostly in foreign universities, many students are lactose intolerant and peanut allergies. Yeah, someone can just reach to the severe health crisis just by eating some peanuts. So these criteria people should be knowing. Okay, so all these data need to be saved, okay, and properly analyzed whenever required. So every piece of data about a student is necessary. So therefore, it is useful to know about different layers of a data warehouse, at least to understand how it works. Okay. So first is the data sourcing layer, okay, where you collect the data from different sources. As you can see, this is the source one, source two, and similarly you can have many. You can have many of them. Okay. So the data sources are there, the more number of nodes and links you have to use. Okay. And that was one of the disadvantages in the Inmon's approach. You have more number of node joins, right? And that is leading to more slower capacity, right? In your analysis. Then is your data staging layer where it goes through the ETL process. ETL process or ELT or ETLT, it's, I mean, depends on the type of data you are handling or which kind of enterprise you are working with. But just to be, I mean, giving you an example, let it be ETL. Okay. So extract, transform, and load, and then you are staging your data here. So therefore, this is known as a data staging layer. After that, it goes to this data storage layer. This is one of the most important layer. So if some person asks you where the data is being stored, so your answer should be where data is stored in a data warehouse. Your answer should be yes, depending on the approach. If it is you are following Inmon's approach, it should be first data warehouse and then segregating into data marts. So either it is data warehouse and data marts, or if you are following Kimball's bottom-up approach, it should be data collection of data marts of particular department integrated into a data warehouse. Okay, so both a collection of data marts and a data warehouse should be in your answer. Okay, so therefore you can see here we have not specified which approach we are using. Okay, so therefore the best way is to put them into a single box, either a data warehouse or data mart together. Okay, after that you can have the data visualization layer or a presentation layer where you can give the data into further analysis. Okay, and you can have these visualization tools like Power BI or Tableau or any other visualization software you are using like Matplotlib or Python, whatever. Okay. So this is one of the simplest ways to explain you the different layers of a data warehouse. After a few slides, we will see how IBM DB2 data warehouse, the architecture of IBM DB2 data warehouse. Okay. So these are all same. I don't have to explain it again. So you can see different layers of data warehouse. One is the data source layer. Already gave you the example. Like maybe you are collecting different transactions, what has happened in your mall. So it's a transactional database. You can also keep log of files when a lot of people are coming to your mall, right? So that you can analyze how many more official staff were to put in that time period. So that only you can know by the log time, how many people came, when they went, and all this data, right? And of course spreadsheets like who bought which items, okay, and which season. So all these are together needed. Fine. So yeah, this is data staging layer. Yeah, it follows this ETL approach. Okay, I already know about. Then the data storage layer. So you can see here data is stored in warehouse and data marts. So you can see data warehouse and then data mart, it is Inmon. Okay, and then this is Kimball's approach, right? So this is top down approach and this is the bottom up approach. Fine. So data mart to data warehouse. Fine. And then yes, I mean you can go with the data presentation or visualization layer where users interact with the stored amount of data. Like you can use these BI tools, business intelligence tools, or different data mining tools and create direct queries with data. Like we were doing in the class with few lectures, we were trying to analyze. I took one SODS data set of last year with different people mark in data analytics. And what we were analyzing, how which student from BioAI or GIS secured the highest mark, right? That we were trying to see. So we have to give a specific type of comments, right? So you can directly create queries with the data set. Fine. Okay. So these are the different tools like you can have. It's the same slide, I think. Yeah. Not much is there. You can do with SQL actually, SQL. Fine. Similar slides. Yeah, you can use Tableau, Looker, or SAP. Okay. I suggest you guys should try to Google this SAP. Okay. Try to Google SAP, at least try to Google about Looker and SAP. So these are, Looker is kind of trending. Okay. So try to just Google about them. What is Looker? What I can do with it? I mean, whatever knowledge I have so far in this course, how can I use it for this Looker purpose? Right? Fine. So you have to create reports or dashboards. Okay. So this bottom picture, what you are looking is kind of an example of a dashboard from Power BI. Okay. So the bottom picture, not a good picture, but yeah, this is kind of interface you will be seeing in Power BI, where you can see different data, like you can play with different data sets, like maybe no coding required. Okay, in it, no coding required in Power BI or Tableau. You just have to put data. It will give you the required number of features, and you can select. Just click. It's just point click mentality. Okay, Power BI and Tableau are just point click mentality softwares where you don't need to know anything about the coding part or heads, tails, anything like that in Python. You just have to click. These are the number of features. Suppose sex is there, male, female, and maybe the smoker is there. So you just have to select those two categorical variables and try to analyze whatever you want to do, like the counts, value counts, how many frequencies, how many males are smoking, how many females are smoking, like that. So very user intuitive. If possible, we will have a 1 hour session on Power BI, if possible in the future classes. Okay. So you can I suggest that the new terms you are seeing here, just try to Google and know about them. Okay. So last year, I had each of these names were given as a project topic to different student groups. Okay. So each of the student groups were coming here and starting to talk about each of these tools you are hearing, like Nine, Looker, Alteryx, RapidMiner, Tableau, whatever. So everyone was trying to give talk here on these topics. However, for your case, we have given you a research work to read and present. Okay, fine. So as usual, like Microsoft Azure, you already know. Let us come to this one general enterprise data warehouse structure or architecture, right? So same, you here in this first layer you have data sources, just a different kind of a picture we are putting here, nothing else. This is the staging area or the sandbox area where it is going through the ETL process. Okay, and this is the enterprise data warehouse. Sorry. Okay. Uh, So as you can see, this is the enterprise data warehouse repository. And I told you already that if you are using an enterprise level data warehouse, then it is better to use Inmon's approach. Okay. If it is Inmon's approach, you should have data warehouse first and then data marts, right? So as you can see here, right? So therefore here data warehouse came first, where you store everything and then you give it to the particular departments like financial or personal information depending on specific department, right? This is the data mart. And then after that you can give it to different business intelligence or analytics tools like for visualization or data analysis, right? So this is the enterprise level data warehouse where IBM falls in also, where IBM falls in that category. So let us look into the next slide of IBM reference architecture, right? So last class we came to know about IBM DB2 warehouse, IBM DB2 data warehouse. So this is one of the, structure of IBM DB2 data warehouse, where you can see instead of the this is the acquisition layer, same. Okay, you can see HR, payroll, billing, ERP. Okay, ERP is used by many institutes to manage the attendance or the mark sheets of students instead of working on it manually on Excel files. Okay, ERP is an automated software system. However, I forgot the full form of ERP. Okay, try to know about the full form of ERP. Okay, I literally forgot. So how many orders have come, what products are being ordered to the university, like that. All information, this is the extraction process, ETL going on here. Okay. So you can see it is the staging layer, then transform and load. Here you have extracted, here you are transforming and loading the data sets here, right? Okay. So this, they have a catchy name here, the data staging layer, where they are calling it IBM InfoSphere data stage. Okay. So it's a scalable ETL platform for delivering real-time integration of your data sets. So then it goes to, your data warehouse here, IBM DB2 data warehouse. And it is ready for your analysis after that. Okay, it can be fed to different analytics. So this topic, one of the your senior batch people, they have given presentation, IBM Cognos Analytics. So a single student from BioA gave a talk on IBM Cognos Analytics, what it is, okay, and how you can do that. Okay. So I suggest everyone to Google this, okay, because you are not giving presentation on this topic, so that should not be a criteria that you should not be knowing about or analyzing about. So please try to Google about the IBM Cognos Analytics, what you can do with it, okay. I mean, these are some of the criteria which you can write in your CV also, right? So now in your final year, they're asking that we can write Python, we can write this, we can write R and all, but what else can we write? So these are some of the, in between the courses it will come. So if you know about this IBM Cognos Analytics, at least you can write that I have opened it, I have created an account, I have tried to analyze some of my data. I will show you that I don't know, I think IBM Cognos Analytics, they have a 30 days free trial. Okay. I mean, all of you can open an account and try to analyze it. Okay. It's free for 30 days. So you can see what all things you can do with it. Okay. And these are the presentation, of course, the data given to to the audience, right? Fine. So these all you know already. Maybe theory, but yes, here I want to show you the same thing. Yeah. This is the IBM Cognos Analytics free for 30 days version. Okay. I hope it is still there. Okay. I hope it is still there. At least last year it was there. Okay. I have not checked this year. So I suggest try the IBM Cognos Analytics free for 30 days. Okay. So you can see what it does. The trial includes a guided demo to explore the solution. AI powered assistant gives plain language answers. Self-service analytics that allows any user to get insights. Okay. Fine. So I strongly suggest that you try this out. Okay. You try this out. Fine. I mean, at least it will stand out as a good uh, idea in your CV. Here it is a good source also. You can sign in with your LinkedIn account. You can sign in with your LinkedIn account so that maybe any other information about IBM data warehouse, anything like that, you can get a feed in your LinkedIn. Okay. Fine. So last year, one of the students gave a talk on this area, and it was a very nice talk, very nice talk from one of the guys from BioAI, and now he's in Chubb. So he's working in Chubb. So it's one of the, I mean, he took the presentations and everything very seriously, because that's what when you present something, you, I mean, it will be inside you, okay? Because you have given all in all in your presentation. We hope, okay? So that's the key idea. So last year it was IBM Cognos Analytics. Uh, Definitely you should try this. Okay. So a bit more about this IBM Cognos Analytics. You can see, prepare your data with build visualizations, okay, find patterns, generate reports, gain insights about the data being fed. So as you can see in this point, IBM has invested more than $25 billion since 2005 to grow its analytics business. Okay. So Cognos Analytics is IBM's AI-fueled business intelligence and analytics software that supports the entire data analytics lifecycle. Okay. I hope you remember during the first week of our course, data analytics lifecycle. Okay. So there are a lot of different, marks were there where it was a flow chart, a closed loop. Fine. So the software market offers many business intelligence tools, and IBM Cognos Analytics is one of the top BI solutions available based on your AI. Okay. I suggest you look now, try your hands on Cognos Analytics. And next semester, maybe you can again try it out, because next semester you might be learning about machine learning. Next semester you will be learning about machine learning and how machine learning can give you some insights on the prediction or the predictive capability of analytics. Okay, what is analytics? We understood in our first few classes. Given the situation now, can we predict what is going to happen in the next few instances, right? So that's what steers us to the next semester of predictive analytics. Okay, so predictive analytics, of course, will use many different algorithms. Like there, you will be learning about k-means. You will be learning about gradient descent. Okay, what is gradient descent algorithm? Okay, gradient descent algorithm, like DSCs will be learning twice. Okay, one in the maybe in their second course of scientific computing, and also on a surface level. Honestly, you will not go into detail on a surface level. You will be learning in your predictive analytics course. However, in the scientific computing course, DSCA students will learn that gradient descent is not all in all. Okay, other students will be learning that gradient descent is very good, but DSC students will be seeing that gradient descent is not all in all. Gradient descent is one of the methods. There are far more better methods than gradient descent. Okay, so you can collaborate gradient descent with RMS like prop and all to make the Adam optimizer for deep learning. Okay, they'll be learning, if possible, more inside details about how Adam optimizer works, which you just write a single line of Python code. Okay, next semester you'll be using Adam optimizer a lot. Okay, you will be importing Adam optimizer again for deep learning or predictive analytics a lot. Okay, just like that. However, I think maybe other students will be learning more detail what is Adam optimizer, how it is being constructed, and why Adam optimizer is used. Okay, even though we are learning about gradient descent, we are still using Adam optimizer in our codes, in our Python codes, right? Why not gradient descent? That means gradient descent fails. Gradient descent fails in some cases. So these are the scenarios you will be learning in the next classes, or sorry, next semester courses. Okay. So therefore, since IBM Cognos Analytics uses AI-based analysis, I suggest you again come back during that course to IBM Cognos Analytics. Okay. This is the time where you are seeing what is going to happen in the next semester. Okay. So try to understand this IBM Cognos Analytics now and also in the second semester. Okay. So when you will be learning about different, this predictive analytics tools, there you again come back to Cognos Analytics and try to see whether any of these correlations are there. Okay, how Cognos Analytics is Cognos Analytics using predictive analytics or any techniques of predictive analytics in them, right? So therefore, don't forget. Okay, don't forget to see back again IBM Cognos Analytics in your second semester. Okay. Fine. So these were the class assignments being given last year. Like many students were trying to understand and give hands-on Power BI and Tableau and Cognos Analytics. Okay, and students have done that. Okay, they gave an introduction about each of them. They took their time throughout the semester to understand how to implement, how to take different examples, and any kind of visualization they showed to the class using either Power BI or Tableau or Cognos Analytics. So maybe in this class we will have a 1 hour session on Power BI. Okay, so we'll see. Okay, any other things we can have? Yeah, I did not cover OLAP, right? OLAP or OLTP. So this is another theoretical aspect which you just need to know. Okay, this term should not be new to you. That's the aim. Okay, that's the aim. By the end of these 2-3 classes, in the previous 3 classes, you know something more than just bar chart, bar graph, histogram, line plots, and all those things, right? Scatter plots or density plots. You know something about how data is being stored. Okay, how data warehouse is different from a pen drive or a hard drive. Okay, what kind of analysis it can do, right? And what is the architecture of a data warehouse? Okay, how data warehouse has different layers and what each of the layers does. Okay, and how different, I mean, well-known organizations throughout the globe, like IBM and Oracle, all those companies, they are using data warehouse. They have produced their own data warehouse, right? IBM DB2. Okay. Fine. So this is another such aspect which you need to know. That is OLAP. Okay. OLAP is referred to as online analytical processing. Okay. Online analytical processing. Right. So this is designed to support analysis of large amounts of data. Okay. So you can see, I hope you remember during my second class, I think I gave you an example of a data cube. I gave you an example of a data cube. So this should sound similar. Okay, this should sound similar where OLAP works with data cubes, right? So you can see this is a dimensional way of organizing your data. Okay, how? Which country it is, then it will go down, which are the states. After it's coming to the states, which are the cities. Okay, and how much amount of rainfall happened in these areas in terms of years or months and days. Which day rainfall happened, which month happened, how much of amount of rainfall happened in this year. Okay, so you can see in tabular form. OLAP reorganizes your data in a tabular form. So you can see here that is meant by rows and columns into multi-dimensional format. Okay, so this is more important, into a multi-dimensional format. Okay, into a multi-dimensional format. What do I mean by that? You can see the OLAP cube here. Okay, so this is what we discussed in our first few slides of our lecture, right? Data cube, where you have region A, region B, region C, region D, and you have years here, and this is the kind of product, like maybe uh, your different products, for example, like your transportation products, like say your tires or something like that, or maybe your health related products. Okay, or maybe human consumption, those products, like anything you can think of. So which product has I mean secured largest amount of sales in which year, and it comes from which city of the country. You understood? Which product A is sold. Suppose I want to know about the, what you can say, any product you can name. Soup. Okay, we have a soup. So this is the company. So K Soup. Okay. So this soup company is want to know this soup. There are three different flavors. One is say chicken flavor. Another is say your mixed vegetable. Another is hot and sour. Okay. So these are the different types of products you have for that particular soup company, and they want, these are the three products A, B, C, and they want to understand which year this product has been sold the most in which region. Okay, in which region? Suppose this one in TVT, right, is sold in TVT. We don't know. Okay, maybe this one in, okay, and maybe this one in say okay, we don't know. So this is the idea. Like after considering lot of different states and cities, we can come to an analysis that the result that this state or this city has given us the largest amount of sales in these areas. So they can foster the sales more next time in these areas, right? So you can see this is the OLAP cube. We will see like this has a faster processing times, and you can see, yeah, this is just for your visualization, just three, I mean cubes, three different axes. Okay, but you can have cubes of more than three dimensions, such are known as hypercubes. Okay, the cubes of more dimensions, like more than three dimensions or something like that, are referred to as hypercubes. Let us come to OLTP. Okay, what is OLTP? So OLTP is nothing but online transaction processing. Okay, yeah, online transaction processing, and these are not designed for complex queries. Okay, this is the difference from OLAP. Okay, OLTP is basically designed for managing simple queries. Okay, OLTP is designed for processing simple database queries. As you can see, like for suppose example, credit card company. Okay, so the system will track the customer's purchase. processes large amounts of simple database updates to account balances. This is a very financial line. I mean, fine. Okay. Whereas you can see OLAP, whereas in OLAP, you can see this is designed for analyzing the purchase data in multiple dimensions. I mean, how many females are, purchasing more amount, which is more, either females or males. If possible, which cities and in which year. Okay. So like that you can analyze. So this is the difference. You can see if you are trying to use OLAP, then it can manage complex read-only queries for analysis, whereas your OLTP is only designed mainly for simple queries. Okay, this cannot handle complex queries. Okay, and OLAP can handle complex queries because of the reason that it can handle data and process it using hypercubes or OLAP cubes. Right? So you can see this is a multidimensional data format. The data is being stored in a multidimensional way, whereas OLTP you are storing in rows and columns. Okay. So these are the two differences between the OLAP and OLTP. Fine. Um, this is what you need to know. I mean, just the intuitive and it should not be unknown to you. There is something known as OLTP, there is something known as OLAP. However, there are books and more information about them on OLAP and OLTP. We are not going much in detail. I'm just giving you on the surface. I'm just giving you some idea and knowledge about on the surface. You can go in detail whenever you like. Okay, fine. So this will lead us to the star and snowflake schema, which I think we should keep it for next class. Okay, let us not discuss it in today's class. However, just a bit of brief that this bottom up and Kimball's model leads us to the star and the snowflake schemas, right? So that will be our aspect in the next class. So, however, I suggest you can go to Geeks for Geeks. Okay, this if you are interested still, try to go into this website, Geek for Geeks. I hope many of you already know about this website. Okay, here they have given a very nice way to tell about the difference between star schema and snowflake schema. Okay, very nicely you can get intuitive ideas about both of them. I just suggest that before coming to the next class, you just read about it. Okay, just have a read on their website. Okay, so very nicely they have mentioned, and yeah, we'll see. So this is it. So we'll stop here.